So in the last video, I gave us a little bit of a refresher of what function composition is and gave us the idea that we're going to build up to a rule that lets us find the derivative of two composed functions if we know the derivative of the individual parts. The only trick that makes calculus a little bit trickier than what we saw in algebra is in algebra, they would tell you what f of x and g of x were. They would tell you those rules. In calculus, they usually give you that compound function and then just ask you to find the derivative of it. So it's going to be our job to pull apart the inside and outside functions. That's what I'm going to call them. So let's take a look at how we do that. All right, so here are two sample functions here. I've got y is equal to the square root of 3x plus 1. So see if you can figure out what the first rule you apply is and then what the second rule you apply is. Well, here we're going to use, and I'm going to use the common notation just so we're in agreement, is that g of x is going to be the first thing we calculate. So g of x, the first thing we do here, if we want to compute this, is we need to figure out what 3x plus 1 is. And that's cool because we know what the derivative of 3x plus 1 is. And once we've done that, we're going to do the second step, which is the output of that. We want to take the square root of it. Okay, so these are our inside function and our outside function. The inside function is the thing that we compute first, and then the outside function is the thing that we compute second. Let's see if we can do the same thing with this example. I'll give you a second to pause the video and think about this. So in this case, g of x is equal to the natural logarithm of x. And f of x, our outside function, is taking the cosine of x. All right, does that make sense? That first we take the natural logarithm and then we compute the cosine of that output. Here are two examples that are going to be a little bit trickier. So what about these two examples? All right, so pause the video and think about both of them, and then I will solve both of them right now. So here, the first thing we're going to do is we're going to compute the cosine of x, and then whatever that output is, we're going to raise e to that power. So here, our inside function is cosine of x, and our outside function is e to the x. And in this last one, this is a little bit of a trick question. Remember that this is this sine squared, having the squared symbol after the sine and not after the x, means that we're computing sine x and then taking the square of it. So that is the first thing we're doing, is we're computing sine x, and then we're taking the output of that function and we're squaring it. If we wanted to do it in the other order, if we wanted to square a number and then take the sine of that, we would write that as y is equal to sine of x squared. We almost never want to do that. This is something that you will probably hardly ever see, if at all. But if we wrote y equals sine of x squared like this, you wouldn't know. Is this squared applying to the x or is it applying to the sine x? And so the solution that mathematicians came up with is to write it like this, which makes sense if you know where it is. So this says, what are you squaring? You're squaring the sine. You're not squaring the x. All right, so this gives you an idea of how to take a compound function and break it down into its inside and outside parts. The next thing we're going to do is we're going to look at the chain rule, which says once you've done those two things, what's the rule for finding the derivative of that compound function?